Hello and good morning, everyone. We're going to begin the 2017 Severe Weather Forecast webinar. My name is David Bennett, and I'm a Product Marketing Manager here for AccuWeather Enterprise Solutions, the commercial line of business within AccuWeather. It is my pleasure to host this webinar along with our main presenters, Tyler Duvall and Don Koash. Before turning it over to them, there are a few updates that I'd like to go over. First, this webinar is being recorded, and copies of the presentation material will be available shortly afterwards. Second, please feel free to ask any questions during the presentation by typing them into the question area of the GoToWebinar software on the right-hand side. I will collect those questions and then direct them at the conclusion of the presentation to either Tyler or Don, depending on the question. If you have any technical video or audio problems, please feel free to use the chat area along the right-hand side to communicate with me directly, and I will solve that problem. With those things out of the way, I'm pleased to introduce our two speakers for today. Our first speaker, who will be giving the 2017 spring forecast portion of our presentation, is Tyler Duvall. Tyler is an expert senior meteorologist here for AccuWeather and the forecast training manager for AccuWeather Enterprise Solutions. Tyler has been providing expert pinpoint weather warnings for more than a decade and is deeply familiar with all forms of severe weather and weather-related risks for enterprises. Tyler has delivered countless critical forecasts and warnings, as well as being a leader among our team of meteorologists. Our second speaker, Don Koash, is the Director of Business Development for AccuWeather Enterprise Solutions. Don joined the AccuWeather team in April 1995 as a storm warning meteorologist and was a Director of Operations in the early 2000s. And now, ladies and gentlemen, Tyler Duvall with the first portion of our presentation.
Thank you, David, for that kind introduction, and welcome everyone to AccuWeather's 2017 Severe Weather Webinar. Like David said, my name is Tyler Duvall. I've been a meteorologist here at AccuWeather Enterprise Solutions for going on 11 years. If you've never heard of AccuWeather Enterprise Solutions, our expertise is really the forecast and warning of hazardous weather for commercial enterprises across all of North America, and really at this point worldwide. Now today we're really going to just focus on one type of hazardous weather. We're going to look at severe weather, and in particular tornadoes. We're going to go back and we're going to look and see, where are we likely to see tornadoes this year, when are they most likely to occur, and how many tornadoes are we likely to see when the year is over. So far this year, we've had 275 tornadoes across the United States. That's nearly double the 15-year historical average to date, and we're only 1 month into spring. So when we look at the agenda for this webinar, we're really going to focus on the spring and summer severe weather outlook. Real quick in the beginning, we're going to take a quick recap of the 2016 spring severe weather season, and then at the end we're going to give Don a few minutes to discuss the SkyGuard service and some of the solutions that AccuWeather Enterprise Solutions can provide to our clients. So severe weather claims dozens of lives and causes billions of dollars in damage each year. The numbers you see here are just for the months of March, April, and May of 2016. During that 92-day period, these three weather phenomena were responsible for 35 fatalities, 100 injuries, and over $3.5 billion in property damage. More than half of the days in spring 2016 had at least one tornado report here in the U.S. Now, that might seem like a lot, but did you know that since 2012, the United States has been plagued by a perpetual tornado drought? So this is a graph of the tornadoes in the United States over the last 10 years. Other than 2008 and 2011, which stick out like sore thumbs on this graph, those were record years with nearly 1,700 tornadoes. The trend over the past 15 years has been pretty steady, with annual tornado numbers across the United States right around 1,200. Now, you can notice when we get to 2012, there's all of a sudden a distinct drop-off from 2012 to 2016. That is what we were calling a tornado drought. And during that time, we were averaging 976 tornadoes. So we are like 250 tornadoes below average over the last 5 years. Now, no one is going to complain about having less tornadoes. The concern, though, is that as the tornado drought continues, the complacency and disregard of the tornado threat will increase. And eventually, when tornado numbers return to normal or above normal, which they will eventually do, we could see an increase in the number of injuries and fatalities. So the question is this year going to be the year that we finally break the drought? Are we going to return to what is normal? Well, so far this year, we've had 275 tornadoes, like I said earlier. So let's go forward and see what the forecast is going to be for the next few months. So in order to create a seasonal forecast, you have to have a group of highly trained meteorologists whose sole purpose is to look at the forecast months into the future. In fact, the forecast that I'm going to show you was created over the winter, and then the graphics that I will show you were developed and created just a couple months ago. So we've had some time to look at this. Our expert long-range forecasters use a combination of weather models, historical trends, and a substantial amount of geophysical and atmospheric data to construct their final predictions. The long-range forecasters, they take all of this information and then they go back into the record books to find analog years that exhibit similar weather conditions to the current year. They compare these analog years to find similar temperature and precipitation trends in order to make a seasonal forecast. In the case of this webinar, in creating a severe and a tornado outlook for months into advance, they compare those analog years to find where and when tornadoes occurred. So in a partnership with our data analyst and expert long-range forecasting team, we were able to use a weighted list of analog years and perform a number of statistical plots in order to highlight regions of tornadic vulnerability. The image on the right is a combined tornado frequency from our analog years. So basically it shows you where tornadoes were most common during our analog years and therefore where they will likely be most common as we go through this year. So based on our analysis for the outlook for the tornado activity from March through May, we are showing areas of the greatest risk for tornadoes this spring in the Missouri and mid-Mississippi Valley. Now when you look at the same information compared to the 15-year historical average, you can see the data change into more actionable insight. And it becomes more clear that parts of Missouri and Illinois are at a greater risk than surrounding areas, and it also indicates that parts of the South are at a lower risk compared to normal. Now the statistical analysis of the weighted analog years also indicated to us that this spring would be below normal with regard to the number of tornadoes. This year, for this spring, March, April, May, we're forecasting 460 tornadoes. The 15-year average is 550, and the average during the tornado drought was 426. So we're forecasting below average for the last 15 years, but above average from what we have seen during the tornado drought. Now, for the most part, we're done with March, right? I mean, it's March 28th. We're almost done with March. So there would be really no reason to show you the March forecast other than see how did it verify. We have the tornado tracks for March 2017, so let's see how it compares with the statistical analysis that we created a few months ago. So all of the little black streaks that you see on this map are tornado tracks from March 2017, so over the last 28 days. Now remember, like I said earlier, this forecast was created over the winter, and this image was actually created by our data analyst in January. And it's actually really amazing how well it lines up with some of the tornado tracks. Just look south of St. Louis with the EF4 that was down there earlier in March. It lines up really well, and so it gives us some confidence moving forward that the analog years are working out really well when we look at April and May. And then when we compare this to the 15-year average, you can see how those areas of Missouri and Illinois really stick out. But it's also interesting to note that areas along the Ohio River, portions of the Southeast, the Carolinas, and even the Western Plains really are below average when looking at tornadoes this year. The other thing that the statistical analysis showed us was that really March was going to be a very busy tornado month. So the normal average is 77. We forecasted 95, which is above average. And so far to date, we have 105. Looking at the next 3 days worth of severe storms across the South, that number could rise before we reach to April. So March has been a very busy month with regards to tornadoes. Now going to April, we are forecasting 165 tornadoes, which is greater and exceeds the 5-year tornado drought average, but is less than the 15-year average. Now 165 tornadoes is still a lot of tornadoes. So April is still going to be very busy as we move, especially through the first part of the month. Looking at the map on the right, you can see that parts of the mid-Mississippi Valley are once again under the gun, areas from just north of Memphis through Nashville. But when you combine it and look at the 15-year, all of a sudden those areas aren't sticking out as much as they did in March. Much of the reason for that is April is a prime month for tornadoes, or at least has been over the last 15 years across those areas. So what this is showing us is that basically, yes, there are going to be tornadoes, but they're not going to be more than what we would normally expect to see across those areas. Now you'll see that dark blue area from Jackson, Mississippi up through Huntsville, Alabama. When you're only looking at 15 years worth of tornado data in order to compare it to the forecast, all of a sudden big events start to stick out. You start to get a bias from those. And perhaps some of you will remember the April 27th, 2011 super outbreak right across that area. That outbreak produced more than 100 tornadoes across that area in a 24-hour period. So that helps bias this a little bit. But what this is telling us is that we aren't expecting an outbreak of that magnitude in that region this April. And then we jump to May, which I think is, you know, for us here in the Central Plains is prime tornado season. Texas, Oklahoma, and Kansas generally see most of their tornadoes in May, prime chasing month for meteorologists across this part of the country. But this year, you can see there isn't the bullseye like there was in March. It's a little bit more spread out. Sure, you have some areas, you know, southwest Kansas near Dodge City, and then you got some areas south of Kansas City, but then you have Indianapolis, you know, Baltimore, D.C., even down near, you know, in the Carolinas and South Carolina near Charleston. And so you look at this and you're like, well, I don't really know how this is going to work out tornado-wise. But when you compare it to the 15-year average, all of a sudden it, you know, really becomes evident that parts of the plains aren't going to see a big May tornado season. We're still forecasting 200 tornadoes. That's still a lot of tornadoes, but compared to average, parts of, you know, Nebraska, Kansas, Missouri, Oklahoma, Arkansas are going to be below average from what they would normally see in May. Now, I always tell people that it only takes one tornado to ruin your day. So really, you can't, you know, this is basically saying, yes, there's a diminished threat, but it's not a zero threat. It's not something that can be ignored. It's something that we have to pay attention to as we go through May, because you can still have, you know, tornado outbreaks through May. It just won't be as much as we have seen over the last 15 years. Now, when we look to the summer, you can see that those, you know, darker, you know, those red colors start to shift north into the upper plains, upper Midwest and northern plains. That's pretty typical for a summer weather pattern. Based on the analog years, we're roughly going to see 315 tornadoes during the months of June, July, and August. When you break it down by month, 175 probably in June, 80 in July, and 60 in August. I think June will be a pretty decent uptick compared to May. We will see probably, you know, the same number of tornadoes, maybe slightly fewer, which is kind of anomalous when you look at the 15-year historical average. And when you compare it to that 15-year historical average, all of a sudden you start seeing parts of the upper Midwest, so Chicago, Milwaukee, Des Moines, are likely to be below average with regard to the number of tornadoes that they would normally see. But areas like St. Paul, you start talking about, you know, northeast Montana, eastern Wyoming, the central Dakotas, those are going to be above average with regard to the number of tornadoes. So when we go forward, we kind of looked at what the spring and the summer will be. Let's go back to that idea of, is the tornado drought over? So we've had 270 tornadoes. We're looking at another 365 through April and May, then another 315 through the summer, and probably another 100 or so to round out the year. So we're ending up with, you know, below average, below the 15-year average number of tornadoes. But if you look at it compared to, let's say, the last 5 years, all of a sudden there's only 1 year, 2015, that is above what we're forecasting this year. So, you know, in the grand scheme of things, the tornado drought continues for a 6th straight year. So we'll have to wait until 2018 to see if it's broken. But we're still talking about 1,000 tornadoes scattered across the United States. So it's still something that we are definitely going to have to pay attention to and think about how we mitigate the risks posed by those tornadoes as we move through the rest of the year. Now, of course, tornadoes aren't the only weather hazard when it comes to severe weather. Like we saw earlier, hail caused over $3 billion in property damage in 2016, and we can use the same statistical analysis of the weighted analog years to see where hail will be most prevalent this spring and summer. So here are the spring analog years. Basically, we're looking for kind of a match to what the tornado plot showed us. Mid-Mississippi Valley, Missouri Valley, these are areas that are going to see a higher density of hail. Just for reference, this is hail for greater than 3/4 of an inch in diameter, so basically pennies and larger for the hail size. Now when we compare this to the 15-year historical average, you can see the above average departures for parts of Missouri, Tennessee, northern Georgia into the Carolinas. That actually matches up really well with a hail event, a large hail event that we had last week on March 21st, where we saw a golf ball to tennis ball size hail across those same areas. So it's showing us that, you know, this analysis is actually lining up really well, and we can have confidence moving forward. Now, if you're wondering why there are dark blue bullseyes over, you know, Wichita, Oklahoma City, Dallas, why there's, you know, an above average bullseye when you get closer to Indianapolis, Raleigh, the reason for that is you tend to get most of your hail reports from major metropolitan areas. In order to get a hail report, you have to have somebody there. So you have more people in these major metropolitan areas, so you're more likely to get hail reports in those areas compared to, let's say, West Texas or Western Kansas, where you have far fewer people. So that also helps bias the information and the data that we put into this a little bit. But what it's showing us is that these areas in, you know, Kansas, Oklahoma, Texas are likely to see below average hail events this spring. Now, when we get into the summer, you can see that shift to the north. You're still talking the plains, the upper Midwest. There's a bullseye in and around Colorado Springs and Denver. And when you compare it to the 15-year historical average, it really kind of shows you that those areas, while there's going to be hail, are going to be below average. I mean, the above average areas are, you know, southeast Minnesota through southwest Wisconsin, Indy up toward Detroit. But you see that bullseye that was near Denver isn't showing up as above average. And the reason for that is, you know, really eastern Colorado, their hail season, if you can call it that, is the summer. And so what this statistical plot is showing us is that, you know, Denver, Colorado Springs, eastern Colorado, there are going to be several hail events, probably quite a few, but it's going to be average, if not slightly below average, compared to normal. So with that, I will pass it on to Don.
Thanks a lot, Tyler. So it has started out to be an active severe weather season. For the next 3 days, we are forecasting a high likelihood of severe weather and tornadoes across the southern United States. So how do you protect your people, property, and profits for your organization? We have a weather monitoring and alerting service we call SkyGuard. We work with each client to understand their emergency procedures and the weather conditions which cause safety, business continuity, and resiliency issues, and tailor SkyGuard warnings to trigger their activation plans. Additionally, our meteorologists are available by phone 24/7 to provide briefings and consultations as necessary to keep everyone within your organization on the same page for developing weather conditions. So we don't just take National Weather Service warnings and repackage them and send these out, but we have certified storm warning meteorologists that are monitoring your facility 24/7 for high impact weather that's going to affect your facility or your organization. So many times you're going to get a warning from SkyGuard before the local National Weather Service issues a warning for your facility. And then we'll confirm you have received the warning in a variety of ways, either on our online portal, via email, or through a phone call. Today we serve about 245 of the Fortune 500, 78 of the Global 100, and hundreds of universities, school districts, and transportation departments across the country. Well, I have so many organizations signed up for the SkyGuard service and no longer depend on National Weather Service warnings. Well, many people are not aware that the warning accuracy from the National Weather Service on a national scale, you know, it could be different for your local area, but it has dropped dramatically in the last few years. On the right are the National Weather Service statistics, and you can see the top graph shows that back in 2011, you could expect an average lead time of 15 minutes on a tornado warning. But the latest year we have statistics, so for fiscal year 2015, the average lead time has dropped to only 8 minutes. So think about that. 8 minutes of warning time is, you know, perfectly fine if you're at home and need to head to shelter or get to your basement. But if you're in charge of a large organization with lots of people and processes, think like a manufacturing facility or personnel center, that might not be enough time to enact your plan. The second graph shows the National Weather Service probability of detection on tornadoes has dropped from 75% down to 58%. So when you consider the graphs that Tyler shared with us, roughly around 1,000 tornadoes reported per year, That's about 400 to 500 tornadoes occurring without warning. So if your organization has numerous locations, that could be a concern because the risk exposure for your organization is much higher because you have so many locations that could be affected. And then let's look at the false alarm problem at the bottom right. Think about that. If you cry wolf too many times, people don't heed the warnings. And that's where we see a lot of our clients gravitate towards the SkyGuard service because the National Weather Service false alarm rate continues to be around 70 to 75%. If those are concerns for your organization, that's really where the AccuWeather SkyGuard service can help out. Typically, we double the lead time to an average of around 20 minutes and reduce the false alarms by 85%. How do we accomplish this for clients? Here's a great example. One service that we have is that's very unique to AccuWeather is that as soon as the National Weather Service has issued a tornado warning for your location or county, a large area warning, we will assess if the tornadic part of the storm will pass within 3 miles of your location. If not, we will send a null notification that our meteorologist has reviewed the warning and determined it is not going to directly impact your location, your facility. It will include the National Weather Service warning in its entirety and the meteorologist that is monitoring your location from AccuWeather and our phone number so you can call if you have any further questions. So 7 times out of 10, you're going to usually get a null notification when the National Weather Service issues a large area warning. So if those are concerns for your organization, that is where the AccuWeather SkyGuard service can really help out, typically with double the lead time. Another way that we help our clients is what we call minutes, not miles. Let me explain. Many other systems automatically trigger a warning for you when a storm is a certain distance away. It's all distance driven, say a 10-mile geofence around your location. If the storm is moving at 20 miles per hour and behaving nicely, then that gives you about 30 minutes before it's over your facility. But what if the storm is moving at a different speed? Like in the summer, where storms are typically moving at 10 miles per hour and very slow, they might not ever get to you or cause a warning activation way too early. Or like in the last couple of weeks with all of the severe weather, these storms are moving very fast, 60 to 70 miles per hour. Setting up a radius to trigger warnings on a 10-mile radius around your location might only give you 8 or 9 minutes of lead time. So back on February 28th, for example, there were numerous tornadoes that went through Illinois and Indiana. Some of the tornadoes were the farthest north ever recorded during the month of February. AccuWeather had about 5 clients that were affected by the tornadoes and had an average of, those clients had an average lead time of 29.5 minutes of warning before the tornadoes hit, which was about 20 minutes more than what the local National Weather Service provided. If you want to look at some additional success stories, you can go to our website. We have quite a number of recent success stories there. So with severe weather starting up, now is really the time to dust off your severe weather action plans. Determine how much warning time you need to enact your plan, and if you need more than an average of 8 minutes of warning time or shutting down, sheltering unnecessarily for every National Weather Service warning is expensive for your organization, then contact us here at AccuWeather on how to get the SkyGuard service set up for your organization. The AccuWeather SkyGuard service is a great weather risk mitigation tool for real-time, site-specific weather monitoring and alerting to help protect your people, property, and profits. While SkyGuard is a great tactical tool to mitigate risk on a day-to-day basis, what if you could mitigate that risk on a longer term, say like for the next few months? And so we're looking more at a strategic level. For example, our Longrange Forecasters provided this map showing the precipitation departures they are forecasting for this upcoming spring. Note the areas of darker green showing above normal precipitation and the orange areas showing below normal precipitation. If you know that really wet weather or really dry weather impacts your business financially, there's ways to mitigate that risk these days. And if you're interested in that, I can put you in touch with some of our partners over at Cantor Fitzgerald to talk more about this. And that wraps up my portion of the presentation. I'll turn it back over to David Bennett.
Tyler and Don, thank you very much for the great presentation. There was a lot of great information there. Now let's start the Q&A portion of our presentation. Again, everyone, please feel free to use the right side chat box to submit and ask any questions that I can read out loud to Don and Tyler. Tyler, looks like we had a question come in here while you're presenting, and it is for you. You mentioned the term analog years. Can you expand on what those are exactly and how you use those to forecast?
Yeah, absolutely. So our long-range forecasters, they look at a massive amount of data when deciding on analog years. This isn't just, what is the weather going to be here in a few minutes or what it's going to be in the next, couple hours. They're looking at a whole bunch of things, solar cycles, long-term weather trends, like this year, above average precipitation in California, whereas just a couple of years ago, we were looking for similar trends with a drought across the, the same areas. They also use long-range weather models that have a good handle on current conditions, and then they look to see what those models predict will happen and if it matches the analog years. And then finally, and probably most importantly, they look at large-scale weather indices. We call them teleconnections in the meteorological community. Things like the El Nino Southern Oscillation, or ENSO. Most of you probably know it as El Nino is the warm phase, La Nina is the cold phase. But there are a bunch of different teleconnections that we look at, the Pacific Decadal Oscillation and the northern part of the Pacific. All of these things help us to pick our analog years. And knowing the correct phase and evolution of these teleconnections can help meteorologists and help these long-range forecasters determine the general weather patterns here in the U.S. Quick example, right now we're in a neutral phase of the El Nino Southern Oscillation. So we're not La Nina, we're not El Nino. But it is forecast to move into an El Nino sometime, late spring or in the summer. And we know based on the past that El Nino conditions typically favor fewer tornadoes than a La Nina does, which is one of the reasons why we have below average tornadoes for May and then through the summer months. So a lot goes into picking these analog years, and some years are easier than others, but it's a pretty standard practice amongst long-range forecasters.
Awesome. Now, Don, this question is for you. Someone has asked if these maps that Tyler is showing, are they available for organizations to purchase to have as a service from AccuWeather?
Yeah, great question. Yeah, they are. The quick answer is that they are available. We have a number of clients that purchase these, and for the most part, the maps are customized based on client need. So we can look at, what we saw here, tornadoes or large hail. Some clients are intensely concerned about precipitation departures or temperature, extreme temperatures, or other types of weather perils. Typically, we can do these on a monthly basis, going out months into the future. Some of our clients, maybe it might even be 6 to 12 months into the future for planning purposes. And then also the maps can be updated very frequently. Some clients get it monthly. They'll update the forecast monthly. Other clients get it updated weekly. So there's lots of different ways that these maps can be delivered, and even the underlying data behind them can be produced and provided to clients as well. So if anybody's interested in that, by all means, reach out to us. We can send you some examples and customize a solution to your specific needs.
Great, and we just had a question come in. I think this will be probably for you, Don. They had asked if these maps and models, as well as the warnings, do they extend into Canada as well?
Yes, they do. We can do this worldwide. Obviously, there's different types of weather perils that we can provide here in the United States versus internationally. But yeah, Canada, United States, and Mexico, we have pretty good data on. Then when we're talking internationally, we need to work with our clients. For example, we don't have a real good tornado database for Europe, but we do have temperature, precipitation, things like that. So we just need to work with the client on their specific use case and meet their needs.
Great. Another question that came in was, does SkyGuard just cover tornadoes, or does that give flood warnings as well? And then, Don, you might want to go over sort of the breadth of warnings that we can provide there.
Yeah, I know we focused on tornadoes. That's obviously an easy one with us going into severe weather season and all the activity. But yeah, SkyGuard, we can monitor for tornadoes, high winds, lightning, snow, ice, extreme temperatures, large hail, all of the different weather perils, flooding. So yeah, typically our meteorologists can monitor whatever is important to the client and whatever they need to take action on. So we align with their action plans.
Great. I think that's all the questions I have on my end that I'm seeing here in the sort of question area. Is there anything else that you guys would like to go over before we conclude here?
I think we're good on this side, David.
Great. Well, great, and thank you, everyone. We really appreciate you being here. And keep an eye out for our next webinar, which will be our long-range forecast for this summer and into the fall. So again, thank you, everyone, for joining us today, and we hope to see you next time. Thank you, Don, and thank you, Tyler, for the great presentation today.
All right. Have a great day, everyone.